Hi learners, today I am going to discuss with you mode, one of the measures of central tendency. I am Dr. Prabhat Dwivedi, Principal and Associate Professor, STEP-HBTI Kanpur. Let's see what the mode is. So first of all, I would like to tell you that mode is denoted by Z, capital Z. The definition given by Croxton and Crowden goes like, the mode of a distribution is the value at the point armed with the item tend to most heavily concentrated. It may be regarded as the most typical or the most frequent value of the series. So this is how Croxton and Cowden define mode. We can understand in simple terms, mode is the most frequent value or the score in the data distribution. It is defined as the value that has the heavy concentration in the series, and this is the value which is found in the series. Highest point of the frequency distribution curve, this mode is. So here you can see in the diagram, this is the highest point. Sorry. Let me show you once again. This is the mode. So that's why this is called a positional measure, because on the graph, if you plot all the frequency on the graph, the highest point will be mode. So the mode can be calculated. One more thing is there, if you have the value of median as well as mean. So this is what the empirical formula is given. Mode is equal to 3 median minus 2 mean. That's how you can calculate mode empirically. Now let's calculate mode for an individual data series. Series is given before you. Now how will you calculate mode? Let's see the working. Here how would we be doing? We would be counting which value is in the highest frequency. That means repeated maximum times. That will be the mode here. So this is just with the observation method. In this series we can do. So it seems like 22 is coming maximum time in this series. This 122, this again 22, 22, 22, 22. So I think 22 is the value which appeared 5 times. Here, none other value has appeared these many times. So mode here is 22. So this is called inspection or observation method. And in case of individual data series, we have seen how we would be calculating mode. So that is something. Now for the discrete data series, how mode will be calculated. Example is given before you. In the problem, we can see that the value is given to you, value of items in the first row, then frequency in the second row. So here there is one problem, that inspection method cannot be used because the data is not distributed symmetrically. How am I saying the data is not distributed symmetrically? Because if you observe these values and frequency goes like 5, then 6, then 8, then 7, 9, then comes down. 8, then again goes up. 9, then again comes down. So this seems to be bimodal. 9 frequency is for 12 as well as for 14. See here. So this is difficult to decide which will be the mode, because the maximum frequency is given, that is 9 for 12 and for 14. For both, for the two values, there is maximum frequency. So that's why to decide the mode, we have to use a grouping method. Now what is the grouping method? We will be understanding with the help of the example. Though the steps are given to you here of the grouping method, like in first column frequencies are given, then in second column we add frequencies into twos, in third column we add frequencies into twos but leaving the first one, in fourth column given frequencies are added into threes, then in fifth column they are added into threes leaving the first one, then in sixth column they are added into threes leaving the two frequencies. So that's how the grouping method goes on. You better understand this grouping method with the help of the example given, worked out ahead here in this slide. So the same problem has been taken which has been discussed in earlier. So let's see here how discrete data series problem of mode is solved. So here this table is to be prepared. Here in first column we can see the values of the observations are put, and then a grouping table, frequency grouping table is constructed that has 6 columns and they are labeled as 1, 2, 3, 4, 5, 6, and then finally analysis table. One column is made for analysis table. So in very first column of this whole table is observation, and first column of the grouping table has the frequencies, given frequencies which are given to you. So now here we see in the given frequency column which frequency is the highest. So highest frequency is 9, and that is 9, that is for two values. So for 12 and for 14. So this is the highest. So now what we do? We give one tally mark to this 12 and then one tally mark to 14 because these two values has highest frequency. Now moving to the grouping for the second column, when the grouping starts, here we group the frequencies into twos. So twos means now 5, 6, that is 11. We put just in the middle of the two, 11. Not in front of any, 5 or 6, but in the middle of the two, that is 5, 6, middle 11. Similarly, 8, 7, how much will be there? Sorry. So 11, then 8, 7 gives you 15, then 9, 8 gives you 17, then 9, 6 give you 15. So now which is the highest? Here we see the highest is 17. So this 17 is the highest in this second column. How 17 is made up of? We see 9, 8 makes 17. That means 12 and 13 will get one tally mark. So again we give one tally mark to 12 and then we give one tally mark to 8. So that is in the second column we do. Now for the third column what we do, just we leave the first frequency and then we start grouping into twos, leaving the first frequency. So first frequency is 5, we leave it. Now we start grouping into twos, that means 6 plus 8. So this gives you 14. Then 7 plus 9, this gives you 16. Then 8 plus 9, this gives you 17. Right. Now 6 will be left because there is no other frequency to pair with it. Now here in this column, third column, we see that 17 is the highest value. How 17 is made up of? 8 plus 9. 8 plus 9 makes 17. That means we give one tally mark to this observation 13 and one tally mark to the observation 14. Now this is in the third column. Now for the fourth column what we do? We group into threes. Here we group into threes. We group into threes. So now 5, 6, 8. How much it is? 19. We write in the middle. Now 7, 9, 8. How much it gives you? 27, 20, how much it is? 24. So this is 24. And now one value will be left. So here, which is the highest value? The highest value is 24. That means we will give tally marking to the frequencies which made 24. So 24, that means 7, 9, 8 makes 24. That means we will give one tally mark to this 7, one tally mark to 9, and one tally mark to 8. This you can say either a frequency or observations, that doesn't make any difference. Now in the fifth column, what do? We again group into threes, but leaving the first value. Here the first value will be left. Now 3. Now 3 are 6, 8, 7. How much it is? 21. We write in the middle. Similarly, next 3 are 9, 8, 9. 9, 8, 9. So how much this becomes? 26. Sorry, 26. This gives 26. Now 26 is the highest. How 26 is made up of? 9, 8, 9. So that means 12 gets 1 tally, 13 gets 1 tally, and this 14 gets 1 tally. Now moving on to the last column. Here we again group into threes, but leaving the first two values. First two values are left. Now we group into threes. We group into threes. So how much? This, and that means 8, 7, 9. That means 24. We write here in the middle. Then again 9, 8, 9, 6. 8, 9, 6 gives you 23. We write in the middle. So which is the highest value in this frequency? That is 24. How 24 is made up of? Here we can see it is made up of 8, 7, 9. 8, 7, 9. So 8 means 10. In front of 8 is the observation 10. Gets 1 tally. 7 gets 1 tally. And this 9 gets 1 more tally. That is the fifth tally. So here we see the highest tally marking is like this is 1 to 10. 11 gets 2. 12 gets 5. 13 gets 4. And then finally 14 gets 3. So here the highest tally marking is 5, and that is for 12. So the observation which has got the highest tally marking, highest tally marked observation is marked value is 12. So mode will be 12. This is how we will be calculating mode for discrete data series. Next example. But before that, here we try to understand how we will be solving, we will be getting mode for the continuous data series. For that, actually we have a formula written in front of you. Here you can see in this slide, mode is equal to L1 plus F1 minus F0 upon 2F1 minus F0 minus F2 into I. So let me tell you what these alphabets denote. So first of all, what we actually do, we find out what is the modal class. For that, two methods can be workable. one observation method. When the distribution of data is symmetrical, then our observation method will work. No issues at all in inspection method. But when the distribution is not symmetrical, that means frequency is like up and down in random way. It's not like from lowest to highest and then from highest to slowly goes to the lowest. Unimodal curve. When unimodal curve is not there, when bimodal or multimodal curve can be made by the observations, by the frequency distribution, then this inspection or observation method will not work. In that case, we need to group the data. And after grouping, once we identified which is the modal class, then we can apply this formula once modal class is identified. So once modal class is identified, then L1 will be the lowest limit of that modal class. F1 is frequency of modal class. F0 is the frequency of pre-modal class. F2 is frequency of post-modal class, and I is class interval. This is what the mode formula is for the continuous data series. Here you can see there are two formula given to you, but they are used when the problem I discussed with the previous slide occurs, and that is what? When you group the data and found two values having same tally, tie-in tallies. In that case, mode cannot be worked out maybe with the help of this or sometimes when your model, you calculated mode by applying this formula, but your mode falls out of the modal class. Like modal class is 4 to 6, but your mode is 2, mode is 3, mode is 8. So mode is not falling in that case in the modal class, and then you are supposed to use either one of these two formula to get the mode, because in that case mode is not valid if it is falling out of the modal class by calculating with the first formula of the mode. So in that case you have to use either one of these formula. So let's take example of the continuous data series. Here this is the example. We have to calculate mode for this data series. Now let's see how does it happen. You can calculate this, then I would give you the answer of this question, but I'm sure that in this formula you may be falling into a problem in which mode may not be falling in the group modal class which it is supposed to fall, right? So that may be the case. You work out this on your own. So learners, now let's see another problem how we will work out mode for discrete data series. So here first column is of classes 0 to 2, 2 to 4 and so on to 12 to 14, and the frequency given is written in the first column of the grouping table. Grouping table, as I told you earlier, we have to make 6 columns, 1 2 3 4 5 6. We label like this. So in first column there is frequency written of the given problem. So here we see the frequencies, they are like 3, 7, 8, 10, then 1, 2, 3. That means the distribution is not symmetrical. If it has been symmetrical distribution, we would have been using inspection method or observation method, but here we see that this is very irregular distribution. That means we have to do the grouping for finding out the modal class. So that's why we have made it a grouping frequency grouping table and then analysis column. So here let's start grouping. As I told you earlier, in first column, first we see which is the highest frequency. So that is the 10 to 6 to 8 class. So we give one tally mark to this class. Now let's proceed for grouping. So in first we group the frequencies into twos. So 3 plus 7 gives you 10, that we write in the middle. Then again 8 plus 10 gives you 18, we write in the middle. 1 plus 2 gives you 3, we write in the middle, and we leave 3 because there is no value to pair with it. So here in this second column of grouping table, highest frequency comes in 18. So how 18 is made up of? 8 plus 10. So we give 1 tally mark to 8, that means corresponding class 4 to 6, and 1 tally mark to 6 to 8. So now let's move for the column 3. So here we again group frequencies into twos, leaving the first value. So we leave the 3. Then we start grouping. 7 plus 8 gives you 15. Then 10 plus 1 gives you 11. And then 2 plus 3 gives you 5. So in this column we find that 15 is the highest value. So how 15 is made up of? 7, 8, that means 2 to 4 class gets 1 tally mark, and 4 to 6 class gets 1 tally mark. Now we move to the fourth column. So here we start grouping into threes. So threes grouping means 3, 7 and 8. So here 3, 7, 8 means 18, we write in the middle. Then 10, 1 and 2. 10, 1 and 2 gives you 13, we write in the middle. So here we find that 18 and 13 are the total values for grouping into threes for column 4. So 18 is the highest value we find here. How 18 is made up of? That is 3, 7 and 8. So we give 1 tally mark to 3, then 1 tally mark to 3, then 1 tally mark to 7, and then 1 tally mark to 8. That is how we proceed. And then we come to the column 4, and here we group into threes, leaving the first frequency. That means we leave 3. Then we make groups of 7, 8, 10. That means 25. We write 25 in the middle. Then 1, 2 and 3. 1, 2 and 3 gives you 6. So we write here 6. So which is the highest value in this column? 25. How 25 is made up of? 7, 8, 10. That means 2 to 4 class gets 1. 4 to 6 class gets 1. 6 to 8 class gets 1. Now we proceed to the last column of this grouping table. So here we leave the first 2 values to group. So after leaving 2 values, we get 8, 10, 1. So 8, 10, 1. Then 8, 10, 1 means 19. We get 19. Then again we left 2 values only. So they will not be considered. So what is the last number here? Only one number is there, that is 19. How 19 is made up of? 8, that means this 1, 4 to 6, 6 to 8, this, and then 8 to 10 gets 1 tally marking. So now here we see this is 1, 2, 0 to 2 class, 1 tally mark, 3 tally marks to 2 to 4 class, 5 tally marks to 4 to 6 class, and 4 tally marks to 6 to 8 class. So highest tally mark is 5, and which is given to 4 to 6 class. So now we found that modal class is here 4 to 6. This is the modal class. So now we apply the formula. Formula is of mode is Z equal to L1 plus F1 minus F0 upon 2F1 minus F0 minus F2 into I, that is class interval. So here in this modal class, the lower limit L1 is how much? 4. So we put the values. L1 is 4 plus. Now here we see modal class is 4 to 6. So the F1 is 8. This is F1. F1 means frequency of modal class. Then frequency of pre-modal class is F0. And frequency of post-modal class is, that is F2. So F0 is 7. F0 is 7. F1 is, we see that 8. And F2 is here 10. So we put all the values. I interval, that is 4 minus 6. So this gives you 2. So we put all the values. So L1 is 4 plus F1 minus F0. That means 8 minus 7 upon 2F1 minus 2F1 means 2 into 8, that is 16, minus F0, that is 7, minus F2, that is 10, into I, that is 2. Now we solve this value. That gives you 4 plus 1 upon how much? That is minus 1 into 2. So how much it is? This is actually 4 minus 2. So that gives you 2. So mode value is 2. Now let's see, mode is 2, whereas the modal class was 4 to 6. So what is the problem now? Problem is that mode is out of the modal class. So when mode is out of the modal class, then that cannot be mode for that problem. That means in this situation, you have to use another formula to calculate mode. Some modified formula through which you can calculate mode. So there are two formula primarily which can be used to calculate mode in such situation. That is Z equal to L1 plus F2 upon F0 plus F2 into I. Or you can use upper limit as well. Then the formula will be Z equal to L2 minus F1, minus F0. It will be F0 upon F0 minus plus F0 plus F2 into I. So you can use any of the formula, like you can use this formula in which you use the upper limit of the class, or this formula in which you use lower limit of the class. So now we have to use this formula for calculating mode in this situation. So now here let's use the first formula. So putting the values in the first formula, L1 is 4 plus F2 is 10 upon F0 plus F2, that is 7 plus 10 into I, that is 2. So here we calculate 4 plus 10 upon 17 into 2. So if you calculate it, this gives you 4 plus this is almost 1.2. So this gives you 5.2. So here the mode is 5.2, which falls into the modal class, that is 4 to 6. So this is actually the mode. So when the problem lies like this, which we have seen here, that mode falls out of the modal class, then we use this formula rather than using this formula in which L1 plus F1 minus F0 upon 2 F1 minus F0 minus F2 into I. We have to use either of these two formula, and then we will get like this, and that mode will be valid mode. So this is how we will be calculating mode for a continuous data series. Problem is also given to you. You can also work it out. And this is, then you can see already worked out here. In this C, these are the classes, and these are the frequencies. So what you do here, you use observation method. Observation method is what? Like if you observe this data set here, like if you plot these frequencies, this will be like this. So since 5, 10, 8, 16, so here 16 is the highest value. There is no neck to neck or bimodal situation. 16 is the highest value. That's why you can simply by the inspection method find out this is the modal class, and this is F1 modal frequency of the modal class, and pre-modal class frequency will be F0. Post-modal class frequency is 14, that means it is F2. So now it's very easy to apply the formula. So how the formula is applied? Formula is applied like this. This is the formula written over here. You applied it and you got this value. Mode is 2400. So here you can check whether the mode is falling into modal class or not. So 2000 to 2500 is the modal class, right? Whereas your mode value is 2400, that means it is falling into this modal class. 2400 value is falling into this modal class. So that's how you calculate the mode for the continuous data series. Now we can take the advantages of mode. Mode is readily comprehensible, easy to understand, easy to calculate. Mode is the best representative of data because it is very much applicable because elections happen. The candidate who gets the maximum votes is elected. That means that is the mode, right? So mode is very useful. It selects the representatives, right? The value of mode can also be determined graphically, as I showed you in the graph. It is the peaked point, highest point in the graph, so it can be shown graphically. It is usually an actual value of an important part of the series. Mode is generally found one of the values of the series. It may not be out of the values available. Maximum times you will find that the value of mode is available in the series. So that is what advantages. What are the disadvantages? Just like it's not based on all observations, because it happens to be one of the values of data set. So that means it is not based on all the observations, not capable of further algebraic treatments, just like mean. Mode is affected to a great extent by sampling fluctuations. True, if you change sample, maybe any other value get the maximum occurrence. So this will be affected by sampling fluctuations. Choice of the grouping has great influence on the value of the data. That's true. If we use grouping method, in that if highest values concentrate in the middle, then the result may be little bit biased. So that is the demerit of this mode. So here we can see how we can choose a better measure of central tendency out of mean median mode based on the data collected on which scale, like nominal, ordinal, interval, or ratio. So here in this series you will find that when values are based on nominal data, mode is the only measure of central tendency to be useful, to be used. When data is ordinal, mode or median can be useful for arithmetic mean to be in place. So but when data is on interval ratio, as we all know, interval data facilitates plus minus sign, whereas ratio data allows plus minus multiplication division all four signs. So these two scales are considered better scales, whereas the ratio is considered the best scale because it offers all the operations to take place. So when data is interval or ratio, in that case we will see whether the data is skewed or symmetrical. If data is skewed, mode and median will be applied. If data is symmetrical, all three can be equally good. So that's how we will be choosing the better measure of central tendency out of the mean median mode. So that's what I think all about mean median mode. So how can we conclude all the measure of central tendency? You can see in this slide, a measure of central tendency tells us where the middle of a bunch of data lies. This is the summary. Mean is the most common measure of central tendency that we have seen in the past. Median is the number present in the middle when the number in a set of data are arranged in ascending or descending order. I have already told you arrangement of data is required to locate the median. Mode is the value that occurs most frequently in the data set, and both median and mode are positional measures, whereas mean is mathematical measure. So that's all about mode, and that's all about measures of central tendency. So thank you so much, viewers, for watching this video lecture full. If you find this knowledge piece worth, you can subscribe, share, like, comment. Thank you so much.